Hi everybody, today we're looking at counting functions between finite sets. We'll also talk about how many of those functions are injective, surjective, or bijective. The total number of functions from a set A with m elements to a set B with n elements is n to the m. The thought is each of the m elements in A have n choices in the set B. As an example, if I have A is the set 1, 2, 3, 4, 5 and B is the set AB, I have 5 elements in A and 2 elements in B. The total number of functions from A to B would be 2 to the 5th, which is 32. So let's say we wanted to look at the total functions from a set S to itself. Our set S is the set 1, 2, 3, 4. Since I have 4 elements in my domain and 4 elements in my codomain, that means I have 4 inputs with 4 possible outputs. The total number of functions would be 4 to the 4th, which is 256. If I want to know how many of those functions are injective or one-to-one, I'm trying to figure out how many of the inputs map to different outputs. Because I'm not having repetition, I can think of it this way. The first element has 4 choices, then the second element has 3, then I have 2 choices, and then I have 1. Multiplying that together gives me a total of 24 different injective functions. When we look at surjective, it means we're trying to find out how many of the functions are on 2, meaning all of the elements in the codomain get used. Again, because I have the same number of elements in my domain and my codomain, I have that same 4, 3, 2, 1 equals 24 choices for surjective functions. When we talk about bijective functions, it means we're looking at both injective and surjective functions. When two finite sets have the same size, injective will imply surjective and surjective will imply injective. So for this example, the number of bijective functions will again be 24. So let's change up the sizes of the two functions. This time, let's let A be the set 1, 2, 3, 4, and B is going to be the set xy. We'll start by looking at how many functions are there from A to B. With 4 inputs and 2 possible outputs, the total number of functions is 2 to the 4th, which is 16. So let's look at how many of those mappings are injective, meaning one-to-one. And the answer is 0. Because I have more elements in my domain than I have in my codomain, I can't have any one-to-one functions. But what about surjective? From our 16 total mappings, there are 2 that are not on 2. Either all of the elements go to x or all of the elements go to y. So our number of surjective functions is 16 minus 2, which is 14. Let's finish this problem up by looking at the number of bijective functions. Since we don't have any injective functions, we know we won't have any bijective functions. Our last example has the sets S and T. S is the set 1, 2, 3, 4, 5, 6, 7. T is the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're first going to say how many injective functions are there from T to S. T is bigger than S, which says I can't have any one-to-one functions, so this answer is 0. When we look at the number of injective functions from S to T, we have to think about how many choices we have for each element. The first element would have 10 choices, the second would have 9, then 8, then 7, then 6, then 5, then 4. When I multiply that together, there are 604,800 different injective functions from S to T. When we look at how many surjective functions go from S to T, the answer is 0. Because S is smaller than T, there's no way to use all of the elements in the codomain. As a quick wrap-up, let's talk about a few key ideas. Injective functions become more restrictive because outputs can't be repeated. Surjective functions require every codomain element to be used. Bijective functions perfectly pair the two sets together.